let me check if we are live or not. So if you all can see me live, can comment in the comment section. So till then, I'm just checking. Okay. So yes. Okay, so we are live now. So hey everyone, hi, hello, good evening, welcome to the session. So welcome to Unacademy ICSE and ISC YouTube channel. So hello Chinmoy, welcome to the session. Very good evening. And students, please keep sharing the link of this video with your friends as well, so that they can also join this session, because this is going to be a very important session for all of you as your term 2 exams are approaching very near. So this is Manisha, your class 10 chemistry educator. These are my credentials. I have 6 years of teaching experience. So you can join me on Telegram for all the homeworks and class notes in PDF format. This is the link of my Telegram channel. And also you can join the official channel of Unacademy ICS and ISC boards on Telegram. The link is in the description box. And special classes also you can join Unacademy, where you can learn from your favorite educators for free. You can engage with your educators via polls. You can clear your doubts in the live special classes. And the special classes links are already given in the description box, from where you can join these special classes. So please let me know, am I clearly audible and visible to all of you in the session? Yes or no? So just give me a, just tell me fast everyone. Okay. So the special class timetables for class 10 is as follows. The special classes of class 10 generally starts at 4 p.m. in the evening. So on 7th, that is tomorrow, we will be having your introduction to Gay-Lussac law and Avogadro's law. On 14th, we will be having your introduction to mole concept. 12th co is a very important session that we have on Unacademy app. That is the orientation session for those students who are moving from class 9 to 10. That is, they are starting their new academic sessions on class 10. So you can join this orientation session, everyone. Very good evening, Chinmoy. Welcome to the session. So all of you can see me clearly. Yes or no, just comment in the comment section. So you can join the Unacademy subscription also. You can take this subscription also and join the plus batches. Hello Kamakshi, welcome to the session. So very good evening. And you, with Unacademy subscription, you can have like maximum benefits. You can learn live from the comfort of your home. You can have unlimited access to all the courses. Top educators of India are taking the classes on this platform. Regular doubt solving sessions you will be having. So just okay. Then practice test, live test series, batches and courses. So many things are on the subscription that you can get. And the pricing is as follows. It's very nominal pricing that we have for Unacademy Plus subscription. And for class 10, you can take the subscriptions right starting from 3 months to 48 months. And you can take it for any period of time. Also, while you take the subscription, do not forget to use my code Manisha Live for 10% discount. So you can do it. Also, yes. Okay. Now, if you are not sure about taking the subscription, that's totally fine. You can skip it, but the thing that you can do is you can download the Unacademy app. No, generally, you can watch all the free special classes, and while watching the means, if you want to watch the free special classes, you will have to unlock them using a code, and that code is Manisha Live that you have to use. Okay. So without any further delay, let's start the class. So our class for today is going to be on the preparation method of all the compounds under study of compound. That is the preparation method of your hydrogen chloride gas, preparation method for ammonia, nitric acid and sulfuric acid. All the 4 compounds that we have in our syllabus, their preparation method we are going to discuss in detail. Lab preparation as well as their industrial preparation, both of these. Okay. Hello Aman, welcome to the session. Very good evening. So let's start the session. The first compound is your hydrogen chloride. So we will start with the preparation for hydrogen chloride gas. Okay. Now, hydrogen chloride may you only have your lab preparation. You do not have any industrial method of preparation. So we will be discussing only lab preparation in this. So lab preparation में what we do, we take a salt that is your sodium chloride and we react it with your concentrated sulfuric acid at temperature below 200 degrees Celsius. So what happens in this particular condition when the temperature is below 200 degrees Celsius, very sorry, I have given the wrong sign over here. When the temperature is below 200 degrees Celsius, only your 1 H plus from your sulfuric acid comes out, and that H plus combines with your chlorine ion to give you your HCl gas, and again your NaHSO4 is formed over here, that is sodium hydrogen sulfate. Hello Ridhima, welcome to the session. So very good evening. Clear everyone? So in this particular reaction, what we observe in the lab preparation of hydrogen chloride, so we will be discussing all the potential questions that could come in your exam, that is in the term 2 examination. So we will be discussing all the important questions as well. Okay. So what we see in this particular lab preparation, your metallic chloride salt we are taking. Which metallic chloride salt we are taking? Your sodium chloride reacting with concentrated sulfuric acid below temperature 200 degrees Celsius to produce your HCl gas and sodium hydrogen sulfate. Okay. Okay, Aman. Chalo. So right now you can see the following questions can be asked from this particular lab preparation. Why NaCl? So if you know the answer, all of you please participate in this question answering session also, so that you can answer the questions in the comment section. So why we are using your NaCl? First reason is that your NaCl is very cheap and it easily available. Okay? So because your, yes, very good Chinmay. So your NaCl is cheap and easily available, so it's preferred over all the other metallic chloride salts to prepare your HCl gas. Clear? Now second question is that why concentrated sulfuric acid and why not like concentrated nitric acid and all. Okay? So concentrated sulfuric acid is non-volatile in nature. It does not evaporate at like temperatures of 200 degrees Celsius or 150 or 180 degrees Celsius. So the non-volatile, it's non-volatile in nature, due to which it is preferred for the preparation of HCl gas, which is volatile in nature. So your HCl is volatile in nature, and for example, if you would have used like HNO3, that will also be volatile in nature. And because this is also volatile, so when you increase the temperature like 150 to 180 degrees Celsius, so what will happen, the vapors of nitric acid will also get mixed with the vapors of HCl, and with this you cannot like get pure vapors of HCl. Okay, so that will be the problem. So to like remove this problem, to get your pure vapors of HCl, we are using concentrated sulfuric acid, which is non-volatile in nature, so it does not evaporate and does not form vapors at the temperature which is provided over here. Clear? Yes, very good. Hello Abdullah, welcome to the session. So very good evening. Hello Noor. Okay, so I hope it's clear to all of you. Now the third question that we have here ki why temperature below 200 degrees Celsius. टेम्परेचर क्यों 200 डिग्री सेल्सियस के बिलो है. वाई दिस इज सो? बिकॉज कि व्हेन यू कीप द टेम्परेचर अबव 200 डिग्री सेल्सियस, व्हाट विल हैपन, योर सोडियम सल्फेट विल बी फॉर्म्ड इन द रिएक्शन. ओके, सो सोडियम सल्फेट के बनने से क्या होगा? सो सोडियम सल्फेट अगर बनेगा, सो दिस इज अ हार्ड क्रस्ट सब्सटेंस. ये कैसा है? ये आपका हार्ड क्रस्ट सब्सटेंस है, which sticks to the wall of the vessel in which your reaction is going on, and due to which what happens, your heating stops and your reaction, further reaction is stopped. Also this substance is very hard to remove, and in order to do so, your glass vessel may crack also. So because of these problems, we do not keep the temperature above 200 degrees Celsius while preparing your HCl gas. Clear everyone? I got 37 in my chemistry pre-board. Got to see the paper today. Very good, Abdullah. Well done. Very, very congratulations. Yes, I too hope कि my student gets 40 out of 40 in their term 2. So you have to be very like disciplined and very attentive for in the classes. Then also you have to prepare well for your boards examination. Okay, so let's come back to the topic. I hope it's clear to all of you कि like why we are keeping the temperature below 200, because above 200 में instead of sodium hydrogen sulfate, your sodium sulfate is formed, which is a hard crust substance and which sticks to the wall of the container in which your reaction is going on, due to which it stops your further heating, and when further heating is stopped, your reaction also stops. Okay, and also what happens, this substance is very hard to remove, so in order to do so, you may crack the glass vessel. So again, your energy, that is wastage of fuel, is also taking place. So because of all these problems, we do not keep the temperature above 200 degree Celsius. Clear everyone? Any doubt in this particular question? Anyone is having any doubt? Tell me fast. Clear? Okay. So now in this case, you can see we have prepared your HCl gas. Now this is the method of collection we have to talk about. So method of collection में which method do we use? Everyone tell me fast. Yes? Okay. So method of collection में what is the collection method that we are using over here? Anyone? So we collect your HCl gas by upward displacement of air. ठीक है? We collect your HCl gas by upward displacement of air. Why do we collect it by upward displacement of air? There are two reasons for that. First is that your HCl is heavier than air. कितना heavy है? It's 1.28 times heavier than air. ठीक है? And secondly, your HCl is highly soluble in water, so we do not collect it over water. ठीक है? HCl is highly soluble in water. So these are the two reasons because of which your HCl is collected by upward displacement of air, also known as by downward delivery. Okay, there are two names for this collection method: upward displacement of air or downward delivery. Clear? Now after we have collected your HCl gas, we need to purify it. So how do we purify your HCl gas? Purification of HCl gas. Anyone can tell me the answer? Yes? Yes, very good, Ridhima. Okay, so purification of HCl gas is done by passing the vapors of HCl through concentrated sulfuric acid. ठीक है, passing the vapors of HCl through concentrated sulfuric acid. So why do we do it? Because concentrated sulfuric acid is a very good dehydrating agent, and your HCl vapor may contain some moisture, and to remove those moisture, what we do, we pass it through concentrated sulfuric acid so that the sulfuric acid absorbs all the moisture from HCl vapors. Clear? Yes, very good. Now why are we passing it through concentrated sulfuric acid only? Why not through why not calcium oxide? Why not your phosphorus pentaoxide? Why not these all? Why only H2SO4? Because these all will react with your HCl vapors. Okay, these drying agents will react with your HCl vapors, which we do not want to happen. That's why we are using your concentrated sulfuric acid. Clear? Yes. And when you use H2SO4, it does not react with your HCl. Clear? So this is all about your lab preparation of HCl. Now, as we know, in the lab preparation of HCl, we have discussed everything, and there is no industrial preparation for HCl gas. So I hope it's clear to everyone. Yes, very good. Hello Shrija, welcome to the session. एयर की गैप की वजह से नीचे जाता है ना? No, Chinmoy. The funnel, when it rises above the surface of water, when there is no HCl gas inside the funnel, in that case, it comes down after your HCl gas comes inside the pipe, and due to its weight, okay, due to its weight, it again goes down in the water. Clear, everyone? So when your what is formed if phosphorus pentaoxide reacts with HCl? So when your phosphorus pentaoxide reacts with HCl, it forms your POCl3 and your HPO3. These things are formed. Okay? Clear, everyone? So these products will be formed, Abdullah, when your phosphorus pentaoxide reacts with HCl. Am I clear to all of you? Any doubt in this particular case? ठीक है, एंड कैल्शियम ऑक्साइड के साथ तो ऑल ऑफ यू मस्ट बी नोइंग कि व्हाट विल बी फॉर्म्ड CaCl2 एंड योर H2O. हेलो अक्षय, वेलकम टू द सेशन. Okay, so I hope it's clear to all of you. Now let's proceed to your ammonia part. Okay, we will proceed to your ammonia part. So ammonia में we have your lab preparations also and your industrial preparation also. So first we will study about your lab preparation. Okay, so lab preparation में what we use as a reactant, everyone tell me fast. Okay, so lab preparation में we are using your ammonium salt and a alkali, ठीक है, and an alkali, that is calcium hydroxide. Clear? So we are using your ammonium salt, that is ammonium chloride, and calcium hydroxide, that is an alkali, to prepare your ammonia in the lab preparation method. So we heat this mixture and what happens? Your calcium chloride is formed, your water is formed, and your ammonia gas is formed. Clear? Yes, very good. Now the ratio in which we are using this NH4Cl and CaOH whole twice is 2:3. The ratio is 2:3 by weight. So this is the lab preparation of ammonia. Now some certain questions we have to like understand in this particular thing. Why we are using 2:3 ratio? Why not the same ratio, or why not the ratio of NH4Cl is taken more? Why this is so, everyone? So we are taking higher ratio of NH4Cl. Why this is so? Yeah, okay. Yes, that's what I'm telling you. We are taking higher ratio of calcium hydroxide by weight. Okay, we are taking higher ratio of calcium hydroxide by weight because your NH4Cl is your NH4Cl shows sublimation. Okay, so your NH4Cl shows sublimation, and if it gets sublimes, अगर ये directly आपका vapor में change हो जाता है, so what will happen? The rate of reaction will decrease. Okay, because calcium hydroxide will be there, but there will be no ammonium chloride to react with calcium hydroxide. So it will be, because of its sublimation, the rate of reaction can decrease. So to counteract the loss of NH4Cl by sublimation, we are using calcium hydroxide in more quantity. ठीक है? So we are just writing the answer for you कि higher ratio of calcium hydroxide by weight is taken because ammonium chloride sublimes, and we need to like counteract the loss of ammonium chloride by sublimation. Clear? So to pay for this loss, to recover this loss so that your rate of reaction does not decreases, we are using more of your calcium hydroxide and less of your ammonium chloride. Am I clear, all of you? Yes, very good, Ridhima. Okay, very good, Shrija, very good, Abdullah. Okay, so I hope ki Chinmoy it's clear to you ki why we are taking your higher ratio of calcium hydroxide, so as to counteract the loss of sublimation, loss of NH4Cl by sublimation. Clear? Now second question कि why calcium hydroxide? क्यों हम calcium hydroxide use कर रहे हैं as an alkali? Why not some other alkalis like sodium hydroxide or potassium hydroxide? Why we are not using these alkalis? Because these alkalis are like deliquescent in nature. ठीक है, ये alkalis क्या होते हैं? They are deliquescent in nature. So deliquescence का मतलब क्या होता है कि they will absorb the moisture from atmosphere and will get dissolved in that absorbed moisture to form their own saturated solution, and hence they become like ineligible for the reaction. That's why we are not taking your sodium hydroxide and potassium hydroxide, because of their deliquescency. Yes, and calcium hydroxide is not deliquescent, as well as it's cheaper than other alkalis. ठीक है, it's cheaper than other alkalis. Very good, Abdullah. And also not deliquescent. Okay, and not deliquescent. Because of these two properties, we are using your calcium hydroxide. It's very easily available. Am I clear, all of you? Any doubt in this particular thing? ठीक है. Now third question is that why ammonium chloride? Why not like some other salts of ammonia, that's like ammonium nitrate and all? Why not ammonium nitrate, and why only ammonium chloride? So the reason for this is that कि your ammonium nitrate is explosive in nature. ठीक है, it's explosive in nature. And second reason for that also not using your ammonium nitrate is कि upon heating it readily decomposes to form your nitrous oxide and water vapor, leaving no residue at the back. So it does not wait to react with calcium hydroxide to form ammonia, and hence we do not use some other salt, we only use your ammonium chloride. Clear? Yes. Very good, Shivam. Very good evening, Shivam. Welcome to the session. So yes, Ridhima, very good, Abdullah. So this is the reason why we are using these all like reactants. Now next question that has to be asked from the arrangement of the lab preparation of ammonia. If you see the arrangement, the flask is kept as tilted. You can see the flask, this is kept as tilted, and then a pipe is being taken to other vessel where it passes through your calcium oxide, where the vapors of ammonia passes through calcium oxide, and then from that vessel we collect it in a container that is kept in the inverted form. ठीक है, this is the entire setup for preparation of ammonia in the lab. ठीक है, so what we see over here, why we are keeping the flasks tilted? क्यों आपका flasks जो है वो tilted है? Anyone can answer this question, why we are keeping your flask in the tilted form? So it's not nitrogen dioxide, Ridhima, it decomposes into nitrous oxide and water. ठीक है, N2O is nitrous oxide. N2O जो होता है वो आपका nitrous oxide है, that is nitrous oxide also known as laughing gas. ठीक है, clear? Abdullah, it's N2O is nitrous oxide also known as laughing gas. Aridhima, it's not NO2. Clear? Yes, very good, Shrija. So that to avoid the trickling back of water, okay, to avoid the trickling back of water into the heated vessel, trickling back of water into the heated vessel, okay, into the heated vessel. Why we are avoiding this trickling back of water into the heated vessel? Because this trickling back of water into the heated vessel can crack this flask or can crack the vessel. ठीक है, we are referring this flask as a vessel over here. Am I clear, all of you? Water does not enter the flask, it will explode. Not basically explode, Abdullah, it will like crack the flask, okay? Because when you keep a glass substance, if your any glass apparatus is there and if it is very heated, if its temperature is very high, so when you suddenly keep something cool on it or you suddenly keep it inside the water, so what happens, there can be a crack appearing in the glass, that is your glass apparatus may break. So to avoid the breaking of vessel by trickling back of water into the heated flask, why we are keeping it in the tilted form. Am I clear, all of you in the class? Any doubt anyone is having? Tell me fast. Till now, any doubt anyone? ठीक है? Now, next thing is that you can see when we are taking these vapors of ammonia, with this we also have the vapors of water, that is moisture with it. So to remove the moisture from the vapors of ammonia, we are passing it through calcium oxide. ठीक है, हम लोग किससे पास कर रहे हैं इसको? We are passing the vapors of ammonia through calcium oxide to remove moisture from it. ठीक है, why only calcium oxide? Why not some other drying agent? Yes, very good. So why only calcium oxide? Because it's basic in nature. आपका calcium oxide जो है वो basic है nature में, so it will not react with your ammonia to form some other substance. But instead, if you use like concentrated sulfuric acid or phosphorus pentaoxide, these reactants will react, these drying agents will react with your ammonia to form certain other compounds which we do not want to happen. That's why we are using your calcium oxide only. Clear? Ma'am, where does the CaCl2 form goes? CaCl2 that is formed over here remains inside the flask, Abdullah. Okay, that is a salt that is formed in the solid state, so it remains inside the flask. It does not go anywhere. Clear? Yes, very good, Ridhima. Am I clear, Abdullah? Is it clear to you? ठीक है? So it remains in the flask, it does not go anywhere. Now, collection of ammonia gas. Can anyone tell me how do we collect your ammonia gas? कैसे collect करते हैं ammonia gas को? So ammonia is collected by your downward displacement of air. Yes or no? ठीक है, downward displacement of air. हम लोग इसको कलेक्ट करते हैं डाउनवर्ड डिस्प्लेसमेंट ऑफ एयर से. व्हाई दिस इज सो? बिकॉज ऑफ टू रीजंस अगेन. बिकॉज योर अमोनिया इज लाइटर दैन एयर. So your HCl vapors were heavier than the air and ammonia is lighter than the air. ठीक है? Yes, very good Ridhima. Upward delivery or downward displacement of air. ठीक है? You can see in this your ammonia gas is being collected, so your air comes downward. So that's why it's known as downward displacement of air. So ammonia is lighter than your air, and secondly, your ammonia is highly soluble in water. Because of these two reasons, we do not collect your ammonia over water, but by downward displacement of air. Clear everyone? Any doubt in particular in these things? Anyone? So I think I have discussed everything related to this lab preparation of ammonia using your ammonium chloride and calcium hydroxide in the ratio 2:3 by weight. ठीक है? Right now we have to discuss your preparation of ammonia from metal nitrides. ठीक है? Preparation of ammonia by metal nitrides. ठीक है? So metal nitrides में what we can take, like we are taking your magnesium nitride, then we are reacting it with hot water. Like why we are using here hot water and not cold water? Because your magnesium is not very reactive in nature, so in order to react it, we have to use your hot water. Clear? Yes, very good. So metal nitride reacts with hot water to produce metal hydroxide, that is here magnesium hydroxide will be produced. And what else will be produced? Your ammonia gas. ठीक है? Ammonia gas will also be produced over here. Similarly, you can use like aluminium nitride and react it with like hot water. What will happen? Aluminium hydroxide will be formed and your ammonia is formed over here. So if I ask you in the preparation method, in the lab preparation method, out of the two given methods, that is the reaction of ammonium chloride and calcium hydroxide to form ammonia or preparation from metal nitrides, which method is more suitable? Can anyone answer me this question? Anyone? Which method is more suitable? Okay. Very good, Abdullah. Yes, the first method is more suitable because that is like more cheaper than this particular method. Clear? So that's why we use your first method. Am I clear? Any doubt in this particular lab preparation of ammonia? Anyone is having any doubt? Very good, Yuvraj, very good, Chinmoy, very good, everyone. Okay. So it's clear, all of you. Any doubt? Let's proceed on to the industrial preparation of ammonia. Yes? So let's proceed on to your Haber's process of preparing ammonia gas. That is your industrial preparation method. Okay, chalo, very good. Haber's process of preparation of ammonia, that is your industrial manufacture of ammonia. In Haber's process, what we do, we prepare your ammonia by the action of nitrogen and your hydrogen gas. Nitrogen and hydrogen gas in the ratio 1:3 to prepare your 2 volumes of ammonia, and your heat is also involved in the reaction. Yes, that's what I explained, Ridhima, ki why warm water is added, because these metals are relatively not very much like reactive in nature, so we need to use hot water in order to like initiate the reaction. We have to give some temperature to it. Clear? Yes or no? Is it clear, all of you? Any doubt? So this warm water is added slowly so that the reaction takes place at a nominal pace and your magnesium hydroxide and ammonia can be produced. Okay, any doubt anyone is having? Okay, so now like what is Haber's process? Haber's process, I told you ki in this process we are using your nitrogen gas and hydrogen gas in the ratio 1:3 by volume, because I told you already कि gases always react in volumes. ठीक है, gases always react in volumes to produce your 2 volume of ammonia gas along with the production of heat. So you can see over here that this reaction is reversible in nature. That means the reaction is going in forward direction also, and the reaction is coming in backward direction also. Yes. So to avoid the reaction coming in backward direction and to take it in the forward direction, we have some conditions to maintain. Okay? We want only nitrogen and hydrogen to combine together and to produce ammonia. We do not want the breakage of ammonia to produce nitrogen and hydrogen gas. Clear, everyone? So in order to take this reaction in the forward direction, we have some conditions to maintain. So conditions to take the reaction in forward direction. Okay, reaction in forward direction. So what are those conditions? Tell me fast. I hope till now you all have must revise this Haber's process. So you can tell me what are the reactions, what are the conditions. So first condition is that your nitrogen and hydrogen should be present in 1:3 ratio by volume. Okay, they should be present in 1:3 ratio by volume. Clear? Yes, Yuvraj, I am already taking your name. So welcome to the session. Very good. So next is your temperature. So what is the temperature that we have to keep over here? Temperature has to be maintained between 450 to 500 degrees Celsius, and the optimum temperature for this reaction to take place smoothly is 450 degrees Celsius. This is the optimum temperature. Clear? Yes, very good all of you, very good. Now what is the pressure that we will maintain over here? So pressure that we need to maintain here is your like 200 to 900 atm. This is the range of pressure that we have to maintain, but the optimum pressure that we should maintain over here is 250 atm. 250 atm is the optimum pressure, the pressure at which this reaction will proceed smoothly. Okay, 250 atm is the optimum pressure that we are maintaining over here. Clear? Okay, very good, Chinmoy. Now, fourth condition is your catalyst. So, what is the catalyst that we will be using here? Your finely divided iron. Okay, we will be using your finely divided iron as a catalyst over here, which will increase the rate of reaction in forward direction. Then the promoter. So, fifth condition is your promoter. So, what promoter we are using? We can use either molybdenum or we can use your aluminium oxide as a promoter. Yes. See Chinmoy, every reaction has some basic needs like which catalyst will be suiting to which reaction. Okay. So some reactions like increases in the rate in the presence of some particular catalyst. So the catalyst that will increase the rate of this reaction in Haber's process is your finely divided iron. So we are using that catalyst. Clear? Yes, no Ridhima, we cannot provide here very high temperature because the reaction is already exothermic. No, I told you कि heat is being evolved in the product side. So your reaction is already exothermic in nature. So we cannot provide like very high temperature, because if you provide very high temperature in exothermic reactions, your rate of reaction will decrease in the forward direction. Clear? So you cannot like provide very high temperature in these exothermic reactions, because increasing the temperature decreases the rate of reaction in case of exothermic reactions. Clear everyone? Any doubt anyone is having? So is it clear? Everything is clear, like why we are providing like intermediate range of temperature, not very high, not very low. Pressure is kept high. Catalyst is finely divided iron. Okay? Now, a promoter I already told you like we can use your molybdenum or aluminium oxide. Then sixth condition is that your nitrogen and hydrogen gas, they should be free from every impurities. Okay, they should be free from every impurities. Clear everyone? They should be free from every impurities. Any doubt in this particular case? Okay, anyone wants to ask anything in this particular reaction? कोई doubt है किसी को? Yes, very good, Chinmoy. So the nitrogen and hydrogen should be free from impurities like your hydrogen sulfide, carbon dioxide, etc. Because if these impurities are present, they can poison the catalyst. Okay? They will surely poison the catalyst. So we do not want that to happen. So we are keeping it free from every impurities. Yes, very good. So this is all about your Haber's process, that is the industrial manufacture of ammonia gas. Now after this we come to the collection of ammonia gas. How do you collect your ammonia gas in Haber's process? Anyone has any idea? How can we collect it in the Haber's process? ठीक है, we can collect it by two methods. First of all by liquefaction. ठीक है, by liquefaction. That means your ammonia will be liquefied very easily as compared to your nitrogen and hydrogen. So if you decrease the temperature of the gas, decrease the temperature of the gases, what you can see कि ammonia liquefies very fastly. Okay, ammonia liquefies very fastly as compared to your nitrogen and hydrogen. So in this way you can easily collect your ammonia gas in the liquid form, okay, as compared to nitrogen and hydrogen gas. Clear? Yes, very good. So liquefaction is the first process of collecting your ammonia gas. Second process is very good, Abdullah. Yes, by absorbing in water. Okay, absorbing in water. So as you all know कि ammonia is highly soluble in water as compared to your nitrogen and hydrogen. So ammonia is highly soluble in water, but nitrogen and hydrogen gases are very sparingly soluble in water. ठीक है, they are sparingly soluble means they are very less soluble in water. So because of its high solubility in water, again your ammonia can be collected by absorbing it inside the water, by absorbing the mixture of gases inside the water. Clear? So in these two ways we can collect your ammonia gas from the Haber's process. Am I clear to all of you in the class? Yes or no? Tell me fast. ठीक है, समझ में आया सभी को? So this way you can recover your ammonia. Yes, very good, Chinmoy. So this is all about your lab preparation, industrial preparation of ammonia by Haber's process. Let me draw the flow chart for this industrial preparation by Haber's process. So first we are taking your compression chamber. This is your compression chamber. ठीक है, compression chamber. In this chamber we are taking your nitrogen and hydrogen gas. ठीक है, so this compression chamber has a pressure of 250 atm. After we are compressing your nitrogen and hydrogen gas together, we are taking it to catalytic chamber. ठीक है, कहाँ लेके जा रहे हैं इसको हम? Catalytic chamber में लेके जा रहे हैं. Hello Sachin, welcome to the session. Okay, hello Disaster, welcome to the session. So we are taking it to catalytic chamber where we are heating it electrically. ठीक है, कि कैसे हीट कर रहे हैं? We are heating it electrically. And what temperature we are maintaining here? About 450 degrees Celsius. So in this particular catalytic chamber, your nitrogen and hydrogen gas will react to form your ammonia. After this, we will take it to the condensing chamber. ठीक है, we will take it to the condensing chamber where the mixture of gases will be cooled down, the temperature will decrease and ammonia will get liquefied. So from here we can easily take out the liquid ammonia, and the nitrogen and hydrogen gases which are left unreacted, they will be sent back to this compression chamber where they will continue and keep on reacting to form your ammonia gas. Clear? Unreacted nitrogen and hydrogen gases. Clear everyone? Hello Piyush, welcome to the session. Hello everyone, I hope it's everyone is doing great. Piyush, I think you are not attending the sessions. That's why you are feeling it not happening quite frequently. Okay. It's not burden disaster. If you like understand them, they will not be any more burden to you, because you hardly have like 20 to 30 reactions overall in your class 10 syllabus. Okay, so I have created a video. I have taken a session on all important reactions of chemistry for class 10. You can watch that session and you can easily remember whatever the reactions are given in your syllabus. Okay, Abdullah, because in condenser chamber, your mixture of gases are cooled. Okay, so mixture of gases are cooled by cooling pipes, so that you can liquefy your ammonia gas and easily collect it. Okay, पीयूष रेगुलरली फ्री क्लासेस अभी थोड़े नहीं हो रहे, बिकॉज लाइक योर सेशन न्यू academic session is starting and your like term 2 examination is also there for class 10, so we will be having like limited sessions. Okay, I haven't cleared my concept yet. Okay, so you need to see all the recorded sessions disaster so that you can clear your concept, and if you have any doubt you can come to me. I will be clearing all your doubts. Okay, so anyone having any doubt in this particular lab preparation, sorry, industrial preparation of ammonia by Haber's process, anyone having any doubt? Yes or no? किसी को कोई डाउट है इस पूरे फ्लो चार्ट में एंड ऑल? अब्दुल्ला, इज योर डाउट सॉल्व? यस, okay, okay, okay. So Abdullah, did you get your answer ki why this mixture of gases are being passed through condenser chamber? Yes, okay. Yes, I will take it. Chapter 13 I have already taken. Harsh, you can go and take it. Okay, you can go and watch it. Okay. Now, after your ammonia, we have your nitric acid. Okay. So nitric acid maybe we have your lab preparation as well as your means large scale preparation, that is your industrial preparation by Ostwald process. So both the reactions we will be discussing. Chinmoy, I will try to do it. Okay, do not worry. I will again bring a session for your study of compounds. If I am unable to like complete the entire manufacturing process of all the compounds, we will complete it in the next session. Okay, so do not worry. Now, nitric acid may first of all we will discuss your lab preparation of nitric acid. So in the lab preparation of nitric acid, what we take your potassium nitrate or sodium nitrate. So we are taking your sodium nitrate and again we are reacting it your concentrated sulfuric acid at temperature below 200 degrees Celsius to produce your NHSO4, that is your sodium hydrogen sulfate, and your nitric acid will be formed. Sodium hydrogen sulfate and your nitric acid will be formed. Clear everyone? In the last 15 days, can I prepare reactions? Of course, disaster key, you can prepare your all the reactions in the remaining 15 days. I will be soon sharing you the strategy like how to revise in the remaining 15 days in the 2 weeks for all the subjects that you have for your board exams. Okay, so do not worry if you haven't prepared your reactions for chemistry. Do not worry at all. I have already taken a session on all important reactions of chemistry for class 10. You can watch that session. Otherwise, you can also watch the session that I will be taking soon for how to prepare or how to revise thoroughly in the last remaining 2 weeks for your board exams. Okay? Chalo. So, nitric acid mein I told you ki we are taking like sodium nitrate and reacting it with concentrated sulfuric acid at temperature below 200 degrees Celsius to produce your sodium hydrogen sulfate and your nitric acid. Yes, sure, Chinmoy. I will surely keep a session for doubts solving sessions only. Okay. So that will be the session when your exams are near. Okay, because the students will have more doubts when 10 to 12 days will be left for examination. So today it's 6 already. So I will be keeping the session most probably on 9 or 10th. Okay. Clear everyone? Please take a sample. Okay, Abdullah, sure, I will try to do that. Okay. So let's come back to the topic. Let's focus. Okay. So here you can see ki we can prepare your nitric acid with your sodium nitrate or potassium nitrate. Okay, and what we are using here, concentrated sulfuric acid below 200 degrees Celsius to produce your KHSO4, that is potassium hydrogen sulfate, and nitric acid. So the optimum temperature for these type of reactions is 150 degrees Celsius. At this temperature your reactions proceed very smoothly. Okay? Now tell me fast, why the freshly prepared nitric acid appears yellow in color. Okay? Why your freshly prepared nitric acid appears yellow in color. Nitric acid is yellow. Yellow or light yellow in color. Anyone can answer this question? Yes? Okay, Chinmay, you are telling the common names of like NaNO3. Yes, it's your chili saltpetre and potassium nitrate is nitrate. Yes. So yes, very good Ridhima, very good Chinmay. Well, एकदम सही बोल रहे हो कि what happens at higher temperatures. Okay, at high temperatures your nitric acid dissociates to produce your water vapors, nitrogen dioxide gas, and oxygen gas. So when you cool the vapors of nitric acid to convert it into the liquid form, cool the vapors of nitric acid to convert it into the vapors form, to convert it into the liquid form. ठीक है? So what happens, your nitrogen dioxide, which is a reddish brown gas, also gets dissolved in the liquid nitric acid. Okay, nitrogen dioxide gas also gets dissolved in the liquid nitric acid, dissolved in the liquid nitric acid, and because of this dissolution of NO2 in liquid nitric acid, your nitric acid becomes yellow in color. Otherwise your pure nitric acid is colorless. ठीक है? Nitric acid becomes yellow in color. Am I clear, everyone? So why is this yellow color appearing? Because of the dissolution of NO2 in liquid nitric acid, because at high temperatures your nitric acid dissociates, or you can say decomposes, to give your water vapors, nitrogen dioxide, and your oxygen gas. Clear? Okay. So I hope it's clear to all of you in the class. Yes or no? ठीक है? So stop means discussing, your chatting among yourself, and pay attention in the class so that you can learn something. It's high time ki you get serious about your preparations. Okay? So stop having discussions among yourself and please pay attention in the class. Okay? So am I clear to all of you why this means slightly yellow color of nitric acid appears? Because of the dissolution of reddish brown vapors of nitrogen dioxide. Clear? Now, the reason why we are keeping the temperature below 200 degrees Celsius, क्यों हम temperature को below 200 degrees Celsius रख रहे हैं? Anyone can tell me this answer? Why we are keeping the temperatures below 200 degrees Celsius? Because at higher temperatures, what will happen? At higher temperatures, the decomposition of nitric acid will increase. Okay, the rate of decomposition of nitric acid will increase. So we do not want to keep the temperatures very high, and we are keeping it below 200 degrees Celsius. Okay, clear everyone? So you can ask me ki ma'am, does it not decompose at 150 degrees Celsius? So the answer is yes, it does decomposes. So that's why we are getting this slight yellow color of nitric acid. But the rate of decomposition is much slower and much low. Okay, but when you increase the temperature, this rate of decomposition will increase. That we do not want to happen. So that's why we are keeping the temperature below 200 degrees Celsius. So this is the first reason for keeping the temperature below 200 degrees Celsius. Second reason is that at higher temperatures, what will be formed? Your sodium sulfate will be formed. है ना? Sodium sulfate बनेगा. And all of you know that sodium sulfate is a hard crust substance. Right now I have discussed this in your HCl chapter also. So sodium sulfate is a hard crust substance which will stick to the vessel walls, which will stick to the walls of the vessel in which your reaction is going on, and it will stop the further heating of the mixture, due to which your reaction will be stopped. And again, taking out this substance from the walls of the vessel is very tough, and in that due course your glass vessel may break. That's why we are not keeping the temperature above 200 degrees Celsius. Clear? And yes, of course, third reason is wastage of fuel. So we do not want to waste our fuel, because when our work is being done at below temperature 200 degrees Celsius, why to give it more than 200 degrees Celsius? Yes or no? Tell me fast. Now, next question that could be asked from this lab preparation of nitric acid is, why concentrated H2SO4 and why not like concentrated HCl? Clear? So why we are taking concentrated H2SO4? Again, the same reason that we have in the we had in the HCl means lab preparation of HCl gas, that is it is non volatile in nature. ठीक है, ये non volatile होता है, due to which it does not form vapors, and hence it does not get mixed with the vapors of nitric acid, because nitric acid is already volatile. So if you use some other acids like concentrated HCl, which is volatile in nature, so that the vapors of HCl can get mixed with the vapors of your vapors of your nitric acid. Clear? Yes. So I hope it's clear to all of you. So now next question. Why only glass apparatus is used for the lab preparation of nitric acid? Why only glass apparatus and not some other apparatus? Why only glass apparatus used for preparation of nitric acid? Anyone? So because your nitric acid is a very corrosive acid. It's a very strong oxidizing agent and hence very corrosive in nature. It's a very strong oxidizing agent and hence highly corrosive in nature. So what happens with whatever surface it comes in contact with, it like deteriorates or it damages that surface. Okay? Yes, very good. So it can corrode all the surfaces with which it comes in contact with. But it cannot react with your glass apparatus. It cannot corrode your glass apparatus, and hence only glass apparatus is used for preparing your nitric acid. Okay? So nitric acid cannot corrode your glass apparatus. That's why we are using your glass apparatus for preparing of nitric acid. Am I clear till here? Anyone having any doubt in this? किसी को कोई doubt है? So all of you, please keep liking the videos if you are really liking it, and do not forget to share this class with your friends as well, so that they can also like understand everything before their exams. Okay? Yes, Abdullah, that I will be sharing with you, like how to remove this yellow color of the acid. How to remove this yellow color of nitric acid. Very good, Chinmay. So yes, absolutely correct. If you pass like dry air or carbon dioxide through the nitric acid, the yellow color will be removed, because it will drive away. The carbon dioxide drives away, removes your nitrogen dioxide, which is dissolved in the nitric acid. Clear? Yes. By passing dry air or carbon dioxide through nitric acid. Okay? So it will take out the nitrogen dioxide from the warm acid, which is further oxidizes to nitric acid. Clear, everyone? So your nitrogen dioxide is being taken out from the carbon dioxide, and carbon dioxide or dry air further oxidizes it to form nitric acid, and hence it does not, like you can remove your yellow color from the nitric acid. So Abdullah, like your carbon dioxide basically what it does, your carbon dioxide or dry air, what it does, it like takes away, it has a very high affinity for your nitrogen dioxide, due to which it takes away your like nitrogen dioxide from the nitric acid, and hence decolorizes it, or you can say it can turn it to colorless. Clear? And further, your nitrogen dioxide is oxidized in the presence of oxygen to form your nitric acid, as it happens in the atmosphere. Am I clear, Abdullah? So nitrogen dioxide will further react with your water and oxygen to produce your nitric acid. Further oxidation of nitrogen dioxide takes place. Is it clear? Tell me fast. Okay, chalo. I suppose there was some technical problem. That's why I was not. Yes, Ravikant, sure, I can explain it once more. Just give me a second. Yeah. Okay, Raj. Okay. So basically what happens ki your like carbon dioxide has like more affinity for this nitrogen dioxide. So it will readily drive out the nitrogen dioxide, and hence it will further get oxidized in presence of water and oxygen to form your nitric acid. Clear? Is it clear, all of you? Please tell me fast. Yes, 20 like will be soon. Yes, Abdullah. Okay. Yes, Raj, welcome to the session. I can see you are a new student to my class. So is it clear to all of you like how this carbon dioxide, by bubbling your carbon dioxide or dry air through nitric acid, how your nitrogen dioxide gas gets like removed from it? Yes or no? Okay, so yes, so 20 likes already happened. So now, or the second method is that by addition of excess of water. Okay, by addition of excess of water. So if you add like excess of water, nitrogen dioxide gas will dissolve in the water, and thus your yellow color of the acid will be removed. Clear? So this is just the opposite of the decomposition of your nitric acid. Am I clear till here? Anyone having any doubt in this? Raj, Abdullah, everyone in the class who were asking this question? Okay. Yes, very good, Chinmoy. Absolutely correct that this is the opposite of your decomposition of nitric acid. So by these two methods, you can remove the yellow color of nitric acid. So this is all from the lab preparation of nitric acid. Now we will proceed to the industrial manufacture of nitric acid. Yes? Okay. Okay, Raj, very good. So now let's study about your Ostwald process. So I will just tell you what is this Ostwald process. So this is used for the large scale preparation of your nitric acid. Large scale preparation of HNO3. Clear? So the time is up and I cannot proceed on further. So we will discuss this Ostwald process, that is the lab, industrial manufacture of nitric acid, and the lab manufacture of sulfuric acid and the industrial preparation of sulfuric acid in the next session, along with the question answer series. Okay? Yes, Chinmoy. So we will be discussing your H2SO4 and this Ostwald process in the next session. Okay. So that's all for today. So before I sign off, I would like to make some announcements to you. So if you are in class 10 term 2, you can participate in this emerge series, which is till your 9th of April, and this is your final chance to practice and ace for your ICSE term 2 examination. This series or this test generally starts from 5 p.m., which are absolutely for free, and you can use my code Manisha Live to enroll for these tests. Okay, so you can download the Unacademy app and give these tests. Yes, Chinmoy, I will try to do so. Do not worry. So like here you can see these are the upcoming batches of your class 10 for the preparation of ICSE term 2 examination. That is your champions batch already started from today. So if you are really willing to like prepare yourself best for the ICSE term 2 examination, you can enroll in this batch by taking the subscription. And if you really want to take the subscription, you can use my code Manisha Live for the 10% discount. And if you're not willing to take the subscription, that's totally fine. Just download the app and watch all the free special classes. And to unlock the special classes, you can use my code Manisha Live. You have given a test. Okay. Yes, Raj, I will surely do a marathon session of chemistry where I will be revising your entire chemistry for term 2 examination for class 10. Okay? So well done, Chinmoy. How much you scored? How much did you score? So this is a batch for those students who are starting their new academic sessions of means for class 10. Gladiators batch already started from today itself. Then we have your guardians batch for those students who are starting their new academic sessions for class 9. So you can just tell your juniors about these batches if they are willing to enroll in these batches so that they can be like full ready for the upcoming academic year. Also on 12th of April on Unacademy app, we are having a class for class 10 orientation where I will be discussing all the strategies and how I will be covering your syllabus and what portion I will be covering first, then what portion will be covered later. So all these things I will be discussing. Also there will be some quizzes in which if you participate and if you are a top scorer, you get a prize. Okay? Those quizzes I will be conducting and you will be having a chance to participate in those quizzes. So do tell your juniors, your classmates about this session. This is absolutely for free. ये बिल्कुल फ्री है. You can enroll in this session using my link Manisha Live. Okay. So we are having a community on Unacademy app which you can enroll yourself. You will never miss any update from any of your favorite educators in which community you have enrolled. You will get your session notes, practice materials, everything. Also, we are having a Bucks Bounty feature on Unacademy where you can report any inappropriate content in the video, and you can do so by filling up the form which is given in the description box. Okay, and you will be getting the prizes also if you are the first one to report that inappropriate content. So thank you everyone for watching the session live. This was all for today. So we will be having our session again on, let me tell you the dates of our next session. So next session will be on, today is 6, no, 8. 8 ko we will have our next session. Okay? 8th April we'll be having our next session. So thank you everyone. Do not forget to subscribe to the channel because without subscribing you won't get the notification of my next upcoming classes. So bye everyone. Thank you so much, and do share this session and your channel's link with your friends as well so that they can also get to know that yes, there is a channel for ICS and ISC. So they can also subscribe to this channel and attend all the classes for absolutely free. So bye everyone. Take care. Thank you so much. Good night. Let's meet again on 8th with a new session.